So first of all, we're going to start out forming magnesium chloride in its solid state, shown at the bottom of our cycle here. And then we're going to show that formation of that magnesium chloride from its elements. Draw this line here. So we've got magnesium solid plus that chlorine gas. And that enthalpy of formation has a value of minus 642 kilojoules per mole. Okay, so next we need to atomize our magnesium to form magnesium atoms. So let's draw an arrow up. And we've got our magnesium atoms. They're going to be gaseous, plus of course that chlorine. Sorry, I forgot to put on here, of course, that we've got magnesium chloride there. So it's 2 chlorine, so it's Cl2 for chlorine gas. And that there is the delta H for atomization of magnesium. And that has a value of positive 148 kilojoules per mole. Right, as we start to build this Born Haber cycle, and we've started off with the magnesium, we've now atomized it. So the next thing to do is to atomize the chlorine gas. Okay, so what we've got is we've got 1 magnesium and chlorine. That's 2 atoms of chlorine, so we've got to be careful here. So let's draw our arrow up because we want to atomize that chlorine, so chlorine gas into its atoms. So we'll have magnesium gaseous plus 2 chlorine atoms. Now the value for the delta H for atomization of chlorine is plus 121, but we've got to multiply that by 2, and that comes out as 242 kilojoules per mole. So that's an important step obviously to make, because we need those 2 atoms there. Right, so now we've atomized the chlorine and we've atomized the magnesium, so our next step is to ionize now that magnesium to convert that magnesium atom into an ion. So we need to show that. Let's draw an arrow up. Now this is quite a large value, so I'm going to draw a larger arrow up. And this is the ionization for the first ionization energy, for magnesium. So we're going to form a magnesium ion, which is in its gaseous state, plus an electron. And we've still obviously got those 2 atoms of chlorine. Now that first value there, that delta H of ionization, is equal to plus 738 kilojoules per mole. Okay, so that is our first ionization energy, but of course we need to then ionize that further to form a 2+ ion. So again, I need to draw an arrow. Now this isn't overly proportional, to be fair, and you'll see why in a moment when I show that second ionization value is plus 1450. So of course the arrows aren't overly proportional, but they're going in the right direction. That's the key thing here. Kilojoules per mole. And that then we're going to have formed those, that magnesium 2+ ion plus our 2 electrons plus our 2 chlorine atoms. Okay, so our next stage from here now is to convert those 2 chlorine atoms into chloride ions, and this term is the electron affinity. And what we're going to have formed from that is we will have our magnesium ion, and they're going to gain those electrons to form those 2 chloride ions. Now again, we have to be careful here because actually the electron affinity for chlorine to gain an electron to form a chloride ion is -349, but of course we need 2 of them, so we must multiply by that by 2, and that comes out as -698 kilojoules per mole. Okay, so we must remember that there. Again, like I said, that you've got those 2 chlorine atoms being forming 2 chloride ions. Right, now our final step is to convert our ions now to solid magnesium chloride, and this is called the delta H lattice enthalpy for magnesium chloride. And we can find this value out as we did in our last video. Oh, I realise now that that's a little bit over, so sorry about that. You can see that we can work this out as we did in our previous video by finding out, because we know that our direct root is equal to our indirect root, so we can now start putting those numbers together. So -642 is equal to the sum of 148 plus 242 plus 738 plus 1450 plus -698. And so what we can say is that -642, once we've added all those up together, comes out as 1880 plus, oh, I forgot to add that in there, plus of course our delta H lat. Okay, sorry, I didn't add that in, but now we know it's delta H lat in there, like so. So now we can say that 0 is equal to 2522 plus that delta H lat, and therefore by rearranging it we can say that our delta H lat is equal to -2522 kilojoules per mole. Okay, so some things to remember that I would say about this whole Born Haber cycle. So if I just flick back there for a second, so some of the common mistakes that people make is to watch out for magnesium chloride is that you've got these 2 ionisation steps involved. Okay, so you must remember to add those in. The other thing is, of course, that there's 2 electron affinities for the 2 chlorine atoms to form those 2 chloride ions. So again, you must multiply that value by 2. The other thing that people often forget to add in are the electrons along the way. So of course, make sure that they get added into the Born Haber cycle as well. Some people say, is it a problem in which order we do them in? Well, you could atomise the chlorine before the magnesium. There's not a problem there. However, what you must show is, in terms of the ionisation of magnesium, is that you need that first ionisation step, and that follows on that second ionisation step. They must go consecutively after each other. However, if you work through this systematically, and you'll be given all the values in the exam as well, there is no reason why you can't construct a Born Haber cycle and actually calculate one of those unknown values from the whole cycle using the information that we've given you on these last 2 videos. Okay, thank you very much for watching.